Welcome back. Today's topic is the introduction to load flow studies. The main objective of this particular lecture is to make you familiarize with the need for conducting the load flow studies in the power system and to get you familiarized with the concept of bus, which we are going to hear most of the times while we are dealing with the power systems. And next, I would like you to introduce the different types of buses which we do generally encounter in the power system. And finally, I'll close it with the significance of a particular type of bus called as slack bus. So I hope by the end of this video lecture, you would be able to explain the need for load flow studies, classify the buses in the power system, identify the variables which are associated with them, and finally, you will be able to explain the significance of the slack bus. Now, moving ahead, load flow analysis of a power system is basically termed most of the times as the analysis of the power system in its steady state condition. So, assuming that the power system is not experiencing any disturbances and is operating steadily, the analysis of that power system, which is in pure steady state, not experiencing any external or internal force, is going to be called as a load flow study. So, what do you mean by analysis? So, analysis is nothing but understanding or identifying, or what we call it as determining, how much power is flowing in the power system, different parts of the power system. We take a transmission power system, we will determine, or we will get to know what is the amount of power which is flowing in the power system transmission lines. We will get to know what is the generation, active power and reactive power generation at the generator end. We will get to know what is the voltage which the consumer or the load is receiving. So these are all the different things which we are more concerned when we are dealing with the power system. So load flow studies gives us an answer to all of these questions, which means that we will get to know the power generations at the generators, we will get to know the bus voltages at the consumers, and we'll get to know what is the power which is being flowed in the transmission lines. Load flow studies, as already been said, it basically comprises of the determination of 4 parameters. One is the voltage, the current, the active power and the reactive power. Or strictly speaking, we are more concerned about 3 complex variables: the voltage, current and the power. All 3 are going to be complex variables. Out of all these 3 variables, we do consider as the voltage and the power as independent variables, and current is going to be determined if we know the voltage and voltage and power. So that's why in the next course of action, we will eliminate the current and we will solely concentrate on the complex voltage and complex power while we are dealing with the load flow studies. And you might wonder, are these only the values or these only the parameters which we will be considering in the load flow studies? No, there is another parameter which is most of the times considered as a constant one, and that is called as the impedance. So different components in the power system do offer different impedances, and that is considered to be a constant one since we are assuming a steady state operation of a power system. So now we are confining ourselves to one constant called as impedance and 2 variables. One is voltage, the other one is a power. With the help of all these things, we are going to determine or we are going to analyze the power system dynamics. Now this is a sample power system. As you can see, we can see generators, power transformers, transmission substation, distribution substation, different types of consumers are there. residential consumers, commercial, industrial, business consumers. There are different types of people, different types of entities out there in the power system, different types of players out there. So our ultimate goal is only one. Are we able to deliver the reliable power to the consumer? So load flow studies help us in one way to understand or assess the health of the power system. So what is that way? That we will be considering now. See, now this is going to be the single line diagram. See, earlier what the structure which I have shown in the earlier figure. Now this has been limited only to this particular figure. These type of figures are called as single line diagrams. They will give us a good understanding of how different elements are there, what are the different elements and how these are being connected in the power system. And the power system always works or always has some sort of constraints. Few of the constraints are, the first one is the generation, how much power we can generate. Now there is always a big question which is going on and on in the power systems. Can't we generate more amount of power and store it when we do and use it when we do need it? No. It may be possible in the future that we can be capable of generating too much amount of energy and using it when we can. But right now, there is a complication of storing the power, of storing the energy. So that's why we are confining ourselves to most of the times to the generation being equal to the demand plus the losses. So assuming that we will be concentrating only on this particular one, that the generation is equal to the demand and losses, and we are going to neglect the storage capacity of the power system. So this is the first constraint of the power system. If there is no storage capacity, your generation must be equal to demand and loss. If you do generate more amount of power and if you don't have any storage capacity, then it will lead to a catastrophe. The generators, the frequency might be increasing, and we do experience non-synchronism of the synchronous machines, which may ultimately lead to collapse of the power system. So that's why the biggest constraint is always about the power which is being generated in the system and how much power is being transmitted and delivered to the consumers. And the second constraint is about the voltage magnitude at various points of the system. At various points of the system, we are more concerned about maintaining our voltage to the rated value or any value which is acceptable to us. And the first priority will be the rated value. So we always choose that the bus voltage magnitude must remain close to the rated value. And the third constraint is the generator. The generator operates within the specified real and reactive power limits. So there is always a minimum and maximum value of how much power you are going to generate or how much power you are going to get from a generator, both the active and reactive power. So it has its own limits. And next is the transmission and transformer. They do have their own thermal constraints. They should not be overloaded. So with all these constraints, you are supposed to operate your power system in a healthier way. And that makes this a problem very complex. Now, moving ahead. Now, why do we have to go for this load flow studies? This has been a question, right, from the start of this video lecture. Okay, sir, we have been listening about all these things, the constraints, etc. Then why we have to go for the load flow studies? Why we need to analyze the power system when it is very complex problem? When it is taking too much amount of time? Why? Yes, we need to do the load flow study. A power system engineer is supposed to do the load flow study. When and why? The first question is, now let us suppose if my demand goes on increasing and if I am capable of generating an additional amount of power to meet my demand, the next question arises, on what transmission lines I am supposed to transmit the power from the generator to the load. So immediately the answer is going to be, I am supposed to select, and on what basis? For that, for getting an answer to that, first of all, we should know about the thermal constraints on the power transmission system. And after that, we have to know what is the power which is presently flowing in the power system. So that we can overload it or we can load it any further. So that's why the load flow studies uses the operation of a steady state. gives us the steady state operation of the power system. That's what I have said. So once we know what is amount of power which is flowing in the power system, then we can think of whether it can be additionally loaded or not. So this means that, let us suppose if the demand is increasing, so I can get an idea of whether I can go with the expansion of the existing power system, or if it is not capable for any further expansion, then I am supposed to choose for a new power system. I am going to set up a new transmission line and new system. So for getting this information, for getting this decision, whether to move on to a new system or expanding this particular system, we need to understand what is the current state of the system. And that is done through load flow studies. It gives us the guidelines for optimum operation of the power system. So one single point from this slide, what we can say, for new design of the power system or for expansion of the current system, we need to know the current operation of the power system, which is clearly being given by the load flow studies. And there is a disclaimer. The disclaimer is that the system must be operating in steady state condition. That we will look into it later on. Now, the second one comes. What do you mean by a bus? That I'll cover in the next presentation.